Hello friends. So today we will discuss about the parts of pressure vessel, that is end closers. So the end closers are the devices or parts which are used at the end of the pressure vessel. So there are two types of end closers are used. One is a flat head enclosures and second one is a form head enclosures. So the types of enclosures are plain form heads, then toruspherical heads, semi-elliptical heads, hemispherical heads, conical heads, etc. So according to the shape, the enclosures are classified as convex heads, in that semi-spherical head, elliptical head, dish head, that is a spherical head with hem, then spherical head without hem. Then in conical heads, the conical head without hem and conical head. Then third one is a flat head. So flat head. So in this diagram you can see the flat head enclosure. So enclosure is the small diameter vessel. Then manhole cover is the low pressure vessel, and cover is the small opening. And here the two important parameters are design parameters are there for flat head, that is a diameter di and thickness of the head. So the thickness of the enclosure head is calculated by using the formula TH is equal to 0.7 di into root of pi by sigma allowable plus c, where di is the inner diameter of the flange, pi is the internal pressure, sigma allowable is the allowable stress, and c is the corrosion allowance. For plain form head, it is generally used for horizontal cylindrical vessel at the atmospheric pressure. Bottom head for vertical cylindrical vessel on concrete slab, d is less than 7. Minimum forming is economical. Therefore, the thickness of the plane form head is calculated by using the formula 0.4 di into root of pi upon sigma allowable plus c, where r is the knuckle radius, RIC, which is always greater than or equal to 0.1 di. Then straight flat length is SF, so that will be equal to 3 times TH to 20 mm, whichever is the larger. So these are the design parameters for the form head, plane form head enclosure, that is the TH, then RIC, DI, and SF. Next is a toruspherical dish head. So the thickness of toruspherical dish head is calculated by using the formula Kf into Rc into Pi by 2 times sigma allowable into Y, that is efficiency, minus 0.2 Pi plus C, that is a corrosion allowance. Then Kf is the stress concentration factor, which is calculated by using the formula Kf is equal to 0.25 into 3 plus square root of Rc upon Ric, where Rc is equal to 0.5 di, which will be less than Rc will be less than 1 times di. Then RIC is always equal to 0.06 times Rc, and Kf is equal to 1.77. Therefore, thickness of the head, that is a spherical dish head, is calculated by using the formula 0.88 Rc into Pi by sigma allowable into Y minus 0.1 Pi plus C. Then SF is calculated by using the formula 3H, 3TH to 20 mm, whichever is the larger, and VH is calculated by using the formula, that is volume of the spherical head dish head is 0.08 for di cube mm cube, excluding the SF portion. Next is the problem. So the cylindrical pressure vessel of internal diameter 3 meter and length 6 meter is subjected to an operating pressure of 0.75 megapascal. Torus spherical head, each with a crown radius of 2.25 meter, are used as enclosures. The shell as well as the heads are made up of a plain carbon steel with a yield strength of 225 Newton per mm square. Double welded butt joints, which are spot radiographed, are used to fabricate the vessel. The serve operating conditions demand the corrosion allowance of 3 mm. Determine the thickness of the cylindrical shell, the thickness of the spherical head, and the storage capacity of the pressure vessel. So here the head is the spherical head. Di is the given data is the Di is the 3000 mm. Then length is the 6000 mm. PW, that is the working pressure, is 0.75 Newton per mm square. Round radius RC is equal to 2250 mm. SY is 226 Newton per mm square. Eta L is equal to 0.85, that is efficiency, weld joint efficiency. Then corrosion allowance is a 3 mm. Therefore, design pressure Pi is equal to the 1.05 times working pressure. So that will be equal to 0.7875 Newton per mm square. Therefore, sigma allowable is equal to SYT upon 1.5. So that will be 150 Newton per mm square. That is the allowable stress. Therefore, thickness of the pressure vessel is Ts is equal to Pi Di upon 2 times sigma allowable into eta L minus Pi plus corrosion allowance. By putting the value of all, that is internal pressure, diameter, then allowable stress, then longitudinal efficiency, then internal pressure, we will get the thickness of the pressure vessel cell equal to 12.29 mm or 13 mm. Then thickness of spherical head TH is equal to 0.885 pi RC upon sigma allowable into eta minus 0.1 pi plus C. So assuming IRC is equal to 0.06 RC, we will get the TH, that is the thickness of the spherical head, equal to 15.3 or 16 mm. Then knuckle radius IRC is equal RIC is equal to 0.06 RC. Therefore, knuckle radius will be equal to 135 mm. Then for straight flange length, SF is equal to 3 times thickness of the pressure with thickness of the spherical head, or 20, whichever is the larger. Therefore, SF is equal to 48 mm. Then storage capacity of the vessel is equal to pi by 4 di square into L plus 2 times pi by 4 di square into SF plus VH. By putting all the values, we will get the volume storage capacity of the pressure vessel equal to 47.26 47.66 meter cube. Then for semi-elliptical head, TH is equal to Kf into Di into Pi upon 2 times sigma allowable into eta minus 0.2 Pi plus C. So this is the semi-elliptical head. Then stress intensifier factor Kf is 1 by 6 2 times plus K1 square. So K1 is the ratio of major and minor axis equal to 2 and Kf is always equal to 1. Therefore, TH is equal to DIPI upon 2 times sigma level into eta minus 0.2 Pi plus C. So this is the semi-elliptical head. Then hemispherical head, the thickness of the hemispherical head is calculated by using the formula Pi Di upon 4 times eta L or sigma level into eta minus 0.4 Pi plus C. Then conical head, bottom head to remove the drainage. So the thickness of the conical head is calculated by using the formula Pi upon Pi into Di by 2 times sigma allowable into eta minus Pi into cos alpha plus C. So alpha angle is generally taken as a 30° for the conical head. Pi is the internal pressure, Di is the internal diameter. TH is the thickness of the head, SF is the side slant length, side length, and C is the corrosion allowance. So SF is generally taken as the 3 times the thickness of the head to the 20 mm, whichever is the larger value. Then attachment on the heads to shape. So for flat head, the attachment can be shown like this. The welding joints are provided, and for form head, the attachment is like this, with the welding joints are shown. Then openings in pressure vessel, inlet and outlet pipe connections, manhole, generally it is 380 mm. Openings designed by the area of compensation method. Area removed is equal to the reinforced by equal cross-sectional area and not volume. So here, in first figure, you can see here for the opening, this area is need to be removed, and to compensate that, the area is added by reinforced by equal cross-sectional area. So this is the opening or inlet and outlet connections for the pressure vessel. Then supports in the pressure vessel. So two types of supports are there. One is a leg support. So using the bracket, leg supports are provided for the pressure vessel, and second one is a skirt support. Then two types of skirt supports are there. So this is the straight skirt support, and second one is a angular skirt support. So here some angle is provided for the support. So this will be called as a angular skirt support. And this is a straight or vertical support. It is also called vertical support. So this is the skirt support. There are two types, and in lug support there will be only one type, that is a straight lug support. Then next is a saddle support. So generally it is preferred for the horizontal pressure vessel. So this type of support is called as a saddle support. So this is the side view of the saddle support. This is also a second diagram which shows the saddle support, and suffering ring is provided. So this type of support is called as a saddle support. So thank you for watching the topic pressure vessel design.